All right. First equation of motion is v is u plus at. U is equal to the initial velocity. Likewise, v is equal to final velocity. A is for acceleration and T is for time. So you should know what each symbol stands for. Now the question is, how do we get these? The first, you can say, method is from the definition. Now you know the definition of acceleration. Acceleration is the change in the velocity with time, isn't it? Acceleration is change in velocity with time. So that is how you substitute the symbols. And if you just cross multiply and rearrange the terms, you will get the first equation of motion as this one. Now another method would be using the graphical representation. For that, since it is between velocities and the times, so we will have a graph between time on the x-axis and the velocity on the y-axis. Velocity in meter per second, as you know, and time is in seconds. So right now we are not taking any values, just to check how we get the same expression. Now suppose, since we have to include both u and v, let me start from some initial value u, and it increases with time. This is the curve given to us. Now next step would be to drop down a perpendicular, and my values for initial speed u, and this one is for the final one v. The time elapsed is t seconds. So we have introduced u, v and t, which can be seen in the first equation of motion also. Next, what we do is we will be finding out the gradient. Now the gradient will be obtained for this particular part of the graph, and the gradient is going to give us acceleration. So for gradient, this perpendicular divided by this base. This is the curve. So perpendicular would be this much, and this would be the base. This part, if you see from the graph, is v minus u, and this is t. So the gradient or the slope is actually v minus u, the perpendicular. That is how we find, isn't it? This is the inclination theta. Theta actually gives you the slope and given by the symbol m. So we get the gradient as perpendicular by the base, because this m is tangent of theta, and tangent is perpendicular upon the base. So perpendicular is v minus u, and the base comes out to be t, and the gradient of the velocity time graph gives us a. All right, so we get a from here. Now a times t is v minus u. Again, we will rearrange, and we are going to get the expression like this. All right. The second equation of motion is s is equal to ut plus half of at squared, right? Now here everything, other symbols you're aware of, only s is a new symbol, and which is displacement. S means displacement. Now this one also can be obtained from the graph. We will not go into the definition thing because this is a bit lengthy and involves so many variables. So we will have a graph like this. This is between t again, and we will have the velocity. So let us have a graph, because initial velocity is involved. Let us take such a graph, and again we will drop down a perpendicular. This time we are going to find the distance covered. So we will be finding the distance covered by this particular portion or the area. So the time is again t over here. This time is t, and we can take the initial velocity as u. It's started with u and the final velocity as v. So there are two methods of finding the area. Either you can find the area of the trapezium or find the area of the triangle and the area of the rectangle. So let me use the area of the trapezium method. So area of trapezium is equal to half sum of the parallel sides. So one parallel side is u, another one is v. So sum of the parallel sides times the distance between them. So this distance, perpendicular distance minded, that is t. So we will write t over here. So we have half u plus v times t, and the area gives us distance. That we have already studied. The area covered by the velocity time graph gives us distance. But if you see these two equations, they're not similar. This can be one of the forms, but let us try to figure out this expression from here. What we find is this is v, right? So v can be replaced from the first equation and we will get this one. Let us try. So we will be using v is equal to u plus at. If we substitute it here in equation number 1, so equation number 1 would imply that s is equal to half. This was u. I'm substituting for v. So u plus at, and 1t is already outside. Simplifying this, this is 2u plus at, and this is t. So again, let us take the terms separately so that it's understood. This times this with this plus the second one at and then times with t. So what you will find if you simplify, first term is ut, second term is half t at squared, and that gives you the second equation of motion. All right. 1 v square is u square plus 2as. This is the third equation of motion. Now what you find, we can use the first and the second to get this one. That can be done. So v is u plus at and s was ut plus half of at square. So what we will do is we will try to eliminate t because we have to have s. So equation number 1, equation number 2, from 1 you can find the value of t. So t is v minus u over a. We will substitute this value in equation number 2. So equation number 2 now suggests s is equal to u times t plus half of a, and then t has been squared away. We will just simplify it. So we can write v minus u upon a over here, and expanding this one, a minus b whole square you can say. So v square plus u square minus 2uv, and this becomes a square. So one power can be cancelled from here. What we finally have is uv minus u square upon a plus v square. This is just mathematical calculation. Then obviously you'll take the LCM, and likewise you will get these terms. You can see plus v square plus u square minus 2uv, and we find that this and this can be cancelled, and we are finally left with v square. This is minus of 2u square and plus of u square. So minus of u square, and this is 2a. Cross multiply on the left hand side, it was s. So 2 times a times s is v square minus u square, or if you rearrange, it is v square is u square plus 2as, and that gives us our third equation of motion.